Hello everyone. In this video, we are going to learn about significant figures. So before getting into significant figures, let's look at a small example. Let's say there is something called, we have some masses given as something like, let's say, one is 5 kilograms, other is 5.0 kilograms, and the other one is 5.00 kilograms, right? Now, is there any difference in the values? Of course, there is no difference in the values. All of them say 5 kilograms. Then why do we have different digits representing? Now, this 5 kilogram means the instrument which has been used to measure it can measure a minimum of 1 kilogram. That means the error that it can have is, this can have any value between, I'll say 4.5 to 5.5. This is the range of the values that it can have. Now this one, 5.0 means the instrument that is used can measure a minimum measurement of 0.1 kilogram. So the error limit for this is 4.9 to 5.1. So it can have any values between 4.9 and 5.1. Now coming to 5.00, the minimum value this instrument can measure is 0.01 kilogram. So the range of the values of this particular 5 kg is anything between 4.99 and 5.01. So we can see that this is the most accurate or minimum error that it can have. So if you look at the digits, this one has one significant digit, this is having two significant digits, and this is having three significant digits. So looking at the significant digits, we can predict how accurate the measurement is. Now let's define what is significant figures. The significant digits or significant figures of any number are the reliable digits plus the first uncertain digit. So that's what it means we have seen. Now, what are the rules of finding a significant figures? All non-zero digits are significant, so there is no problem. Now, before getting into the rules, let's see. There are something which are conversion factors. Like I say 1 kilogram and somebody else says it is 1000 kilograms. Sorry, 1000 grams. Now, the instrument has measured 1 kilogram, but when I'm expressing it in grams, it becomes 1000 grams. I cannot say that this is more accurate than this because the same instrument has given me the value. I'm just converting. So what do I say? I can write it as 1 kilogram equal to 1 into 10 cube grams. So these zeros are expressed as powers of 10. So all the zeros which can be expressed as powers of 10 can be considered as conversion factors. So all zeros which can be expressed as powers of 10 are non-significant and everything else is significant. So that's what the rule says. All the non-zero digits are significant. All zeros occurring between two non-zero digits are significant. Zeros lying between decimal point and the first non-zero digit on its right side are not significant. This is not significant because this can be written as 4.53 into 10 power minus 4. I can express it as a power of 10. All zeros appearing on the right side of decimal point are significant. Here, these cannot be expressed as powers of 10, so they are significant. So for a number having absolute value greater than 1 without any decimal, the trailing zeros are not significant. So something like this, like as I said, 1000, these three zeros are not significant. So, and the number of significant figures does not vary with the choice of different units. So the conversion doesn't change the number of significant figures because that doesn't affect the accuracy of the measuring instrument. Then let's look at the rules of rounding. Rules of rounding are, if any digit that has to be rounded off is greater than 5, then we go for the next digit, and if it is less than 5, we go to the we stay with the same digit. Something like, I'll take it as 2.453. So it can be rounded off to 2.45. Here 2.456, it can be rounded off to 2.46. Now if the digit to be dropped is 5 followed by digits all of which are not zeros. So if all of which are not zeros, then the preceding digit should be increased by 1. So if I have something like 2.4550001, then it would be 2.46. If the digit to be dropped is 5 or 5 followed by 0, then the preceding digit does not change if it is even. So what does it mean? Again, I'll say 2.445. Now 4 is even, so even if it is 5, it will not change. So this would be written as 2.44. If the digit to be dropped is 5 followed by zeros, then the preceding digit is increased by 1 if it is odd. So So if the preceding digit, I'll take this one, 2.455, I'll take it as. Now 5 and 0, so this is odd, so the answer would be 2.46. So this is something that is that many people don't know. Rounding off when we have 5. So the preceding digit being even or odd makes a difference in that case. How do we do operations in significant digits, algebraic operations? So when I add two numbers, in addition or subtraction of two or more numbers, the answer should have the same number of significant digits after the decimal as one of the numbers as one of the numbers has, if that is the minimum number of significant digit. What do I mean by that? Like after the decimals here, how many digits I have? 1, 2, 3, 4, 5. I have 5 digits. After the decimal, how many digits I have? I have 2. So the answer should have 2 digits because 2 is the minimum number of digits we have after the decimal. So the answer should have 2 significant digits or 2 digits after the decimal. So the answer has 2 digits. So in addition and subtraction, the digits after the decimal comes into picture. Same thing, 4.732 and 3.2, only one digit, so I'll have one digit. 4.5 and 1.3, only one digit, I'll have one digit in the answer. 4.37, whatever. So they have written it this way. I hope you could follow this. Now let's look at the other thing, multiplication and division. In multiplication and division, the number which is having minimum digits, the numbers which are multiplied are divided. So whichever is the number with minimum digits, those number of digits would appear in the answer. For example, 3.784 I have 4 digits, 5.2 I have 2 digits. So because 2 is the minimum digits, I'll get the final answer should have 2 digits, something like this. Again 3.8 and 0.125, 2 is the minimum number of digits, the answer should have 2 significant figures. 9.58 by 3.2, 2 is the minimum digits, the answer should have 2 significant figures. So that's about significant figures. Hope you could understand what we have done. Thank you very much.